Welcome to Study Loop.
Okay, so we have the following reaction, and it has reached equilibrium. Um, Basically, we have solid magnesium reacting with sulfuric acid to form magnesium sulfate. Actually, this is aqueous. And hydrogen gas, as well as heat, which you can put as a triangle. That's often the symbol for heat in chemistry. Okay. And so, what these questions are about is about effectively saying, what if I take something like magnesium and I reduce the amount of it after I've reached equilibrium? What will happen? Or I take the gas and I increase the amount of it, or right. Usually, this is assuming we're talking about a sealed reaction vessel. It's kind of important if there were more information up here that may have mentioned something like that. But we're going to assume we're in a sealed reaction vessel. We'll talk about why that matters. Okay. So first, I'll just kind of mention what this is kind of like. Imagine, if you will, that I've got a system of pipes, really just a U-shaped pipe, right? And if I fill water up in this pipe and I fill it up to like here, for example, and then I have a siphon and I can pull water out of one side, right? This water level that I've drawn on the left will go down if I siphon water out from the left-hand side. And what's going to happen is that some of this water will get pushed over such that eventually they'll both reach a new equilibrium, right? Like I'm pulling water from the left, but that means the water on the right has to push over so that they both reach the new height. And that's the same thing here. If I pull magnesium out, then I push the reaction backwards to replace the magnesium we lost. If and then we can consider the opposite of that too. Like, let's say I have, um, I don't know, this much water in my system. Okay. So it levels out, it comes to equilibrium, and then I pour a bunch of water in, right? And all of a sudden, my new water level is here, right, on the left hand side. Well, once it comes to equilibrium, what's going to happen is I'm going to have a little less of that water over here and a little more of it over here, right? Some of this water is going to move over to the right hand side so that it's even on both sides. We'll reach a new equilibrium, right? Even though initially I added water to the left hand side, eventually some of that will flow to the right hand side until the left and the right hand side water levels match. Okay, same idea here. If I pump a bunch of magnesium in the left hand side, then this reaction is going to push forward, right, to kind of even things out, right? So if you add or remove things from one side of the reaction, they will get added or removed from the other side of the reaction. That's the whole idea here. Okay. So when they tell me that we remove H2, okay, we remove H2, then the reaction will counteract whatever we do. So if we remove H2, the reaction, what does it do? It makes H2. Right? So it's going to try to push back against whatever we do. Right? We poured water in the left-hand side, then the water pushed over to the right-hand side to even it out. We remove H2, the reaction makes H2. If we remove water from the left-hand side of our contraption by siphoning it out, the water pushes back to restore it, or at least even things out. So if the reaction makes H2, what direction does the reaction proceed? What direction, forward or backwards, does the reaction proceed if it needs to make H2? Reaction needs to proceed forward, right? Because that's the direction that has H2 as a product, right? Pushing forward makes H2. Okay. And if the reaction pushes forward, what happens to the concentration of magnesium? Magnesium is consumed as we move left to right, right? So if the reaction pushes forward, magnesium concentration goes down. Okay, so that's the steps here. What do we do? What does the reaction do to counteract that? Does the reaction push forward or backwards? And then what does that mean for magnesium? Okay, reaction vessel is cooled. Reaction cooled. Okay, so if the reaction is cooled, what does the reaction have to do to counteract that? Sorry, not react. Let me just say we cool vessel. Okay, what will the reaction do to counteract that? It's going to heat the vessel or make more heat. Reaction makes heat. I put a triangle. Okay. So if the reaction makes heat, does that mean the reaction has to push forward or backwards? Heat is a product of the reaction, so the reaction must push forward. Okay, and if the reaction is going from left to right, what does that mean for magnesium? Well, magnesium is on the left here, right? And when we say magnesium, we're just talking about this. We're not talking about this magnesium. Maybe that was confusing earlier, but when they say the concentration of magnesium, they mean this, okay? Okay, so the reaction pushes to the right. It's the same as before. Magnesium is consumed as we move from left to right, so magnesium goes down. Okay. Next, the internal pressure of the reaction vessel is increased. Increase pressure. Okay, so what does the reaction do? Reaction will counteract this. It will decrease the pressure. Okay, well, what side of the reaction has anything to do with pressure? It's H2 again, right? We make gas as we move from the left to the right, right? And gas increases the pressure. These solid and aqueous things don't have anything to do with pressure, okay? All that matters is gaseous species, meaning as we move from left to right, we create H2 gas, and creating H2 gas increases the pressure. It's like when you blow air into a balloon, it increases the pressure in the balloon. Well, moving from left to right creates gas, which is like blowing air in, increasing the pressure in our system. Okay, so H2 gas, if we're increasing the pressure, like that's what we're doing with the controls, the reaction wants to counteract that by decreasing the pressure, then it needs to decrease the concentration of H2. Right? The only way the reaction can decrease the pressure is to push to the left and get rid of H2. Right? So this time the reaction pushes backwards. Well, what does that mean for magnesium? Well, if we go from right to left, we're making magnesium, right? When we go from left to right, we're destroying magnesium. Right to left, we're making magnesium. So now the concentration of magnesium will increase. So that's the whole idea here. What did we do? What will the reaction do to counteract that? Does that mean going forward or backwards? And then depending on whether we went forward or backwards, what happens to magnesium?